Yo, what's up everyone? We are back for day 2 and today we are going to write a contract, write deploy scripts for it and write tests for it. So what are we building today? I would like to introduce you to this concept called wallets. Now what are wallets? Wallets are basically anything that you see, like from where the money flows in crypto, where the money flows in currency. So this is something called a wallet. Now what we are building today is actually called a shared wallet, which involves a concept of ownership in Web3, which is kind of ironical. There is no ownership in Web3, but yet we are ensuring that we have a wallet which is shared among multiple spenders who can spend from that wallet, and yet the spending is controlled. They cannot drain the wallet completely. They can just spend whatever allowance has been given to them. So imagine this as a pocket money wallet. There are two children. There is one parent who is the owner of this wallet. He or she deposits some money in this wallet and allow sets allowance for both of the children or how many children they have, and the children can spend from the wallet according to that amount of money. So this is very similar to what we built yesterday, which was a bank contract which has deposit and withdraw. Now there is an extra feature of ownership and sharing here. So let's get right into it. Today we are not going to do the command line deployment command line. We will write a deploy script for it. So let's go 50 days and not day 1. So ls, so we can make a new directory day 2, cd day 2, and we can directly open this up. Yep. So once we set up the ID, I guess we all know what to do, and we have to do a forge init, which sets up an empty Foundry project here with a counter, test, counter scripts, and counter source. Let's delete all three of these. Delete. Okay. So the contract that we are going to write is shared wallet.sol. Okay. So let's first define the architecture for this wallet, or the skeleton for this. So there will be some functions. So first function would be deposit, which as yesterday will be payable function and will be called by only the owner of this contract. Now this is something called access modifier, which is used in a lot of other languages. In Java there is private class, there is public class. Similarly, the functions can also have access modifiers here. Now what will this access modifier ensure? That this wallet is only controlled by parent, and some other third party person is not going to involve while they are trying to deposit more money in this or have any other actions over this wallet. Okay, so there will be this only owner deposit function. Then there will be a set allowance function, right? Set allowance function. Now I think this contract needs a constructor. So constructor, if we add a constructor is basically what parameters you initialize your wallet with. Now this is something that can be brainstormed about. Either we can have a set allowance function, or we can have a constructor which can have all the addresses that are passed so as to become the spenders. But I think we can have both of these somewhere. Somehow we can have both of these, and let's see how we go about it. And then is withdraw function as yesterday. So these will be called by only spenders. So only spenders can call the withdraw function. Nobody else can do that. Okay. So I think this is something that is the complete skeleton of what type of functions do we need. And let's get back to the ID. Let's give the license identifier fire MIT, and the pragma solidity. I'm not sure what version we used yesterday, but I think can be anything. I think let's go with 21. Oh, sorry, 25. Yeah. Now the contract will be shared wallet. Okay. So the contract will be shared wallet contract. Now what the contract needs is a function called deposit, which is public, not public, payable only owner, owner. Now, how do you define an access modifier here? So let's go. The keyword is modifier, as we can see here, modifier only owner, and the person who deploys the contract by default becomes message.sender for that contract. Okay, so I did multiple brackets, and we need that require of message.sender should be owner. Okay, so whoever is calling the function has to be the owner of the function. So where will we set the owner of the function? We'll set it in the um, constructor of the contract. Now let's make an error which is called error not owner, and we can revert to this error like this. If reward not owner, and then if it is, that carry on with whatever it is. Now owner is not defined here, but I think we all know that owner can be defined as an address public. Like we don't want to hide who's the owner of this, right? So we put some lines here, and then we define address. Why am I misspelling things today? Owner. Okay, now this is used here. Now this is used here, public owner. Did you intend to add public? So yeah, this function will be public. That means anyone can call, but only owner can actually access this contract. So there is another keyword that can be used, which is external keyword solidity, right? What does this ensure is, let's read this talk. This is a great talk of external versus public. So there is an answer. External is basically gas efficient. So just an insight, every function call uses gas, which is real ETH, to call the functions. External is something that uses less gas. Basically external is basically it can be called externally. Public is also that, but yeah, this is a good doc. I'll link this to here. Yes, and the main difference is it cannot be accessed internally. So any of the functions cannot be calling deposit. So let's say I have this function new and public. I cannot call deposit here. It will throw an error for me because this function is not internally callable. So that is that. And what will this ensure? That the deposit is only called from externally from the contract. So what will happen here is this is a payable function, hence we need the message value to be equal to the amount that is sent. So we can either ensure an amount here, or we can just ensure that the message dot value is not equal to 0, because there is not, like bank contract, we do not have a fixed amount of deposit. A parent or a controller can deposit any amount of money that they want in the contract. So deposit cannot be 0, and we call this if message dot value is equal to 0, then whatever. And if it is, we emit an event. Remember what events are. Events are the listeners that are emitted when any function is called, any activity, any interaction is successful or unsuccessful in a contract. So this is what deposit successful is. And once the deposit is successful, we emit deposit successful for message.sender and message.value. So how much money has been deposited is set here. Now let's find a constructor for this contract. Constructor Now owner should be equal to message.sender. Okay, I think we should pass the addresses of allowances in this function only, as we can later set allowances for a fixed set of children or a fixed set of user spenders. This, okay. So there should be an address mapping. So let's write an address mapping address to u into 56, which will be called public spenders allowance. Okay, is that okay? I think this will ensure that the spender's address is mapped against an allowance here. And yeah, I mean, this does not have any problem. Yeah, I think this is okay. I think we should keep it two-step. Let's just initialize the constructor here, setting the owner of the function, and then we should have another function called set allowances, and this will take something that we have not yet discussed here. It is called address and an array of an address. So any function, any data type here, let's say this address, when we write this as this, it will be called as an array of address. This is very used to with people who use C++ and stuff like that. So this is a very relatable language for a lot of folks here. So why is this mapping? I expected identifier but got mapping. I don't think this is a problem. So set allowances, which will be public and only owner. Owner. I think we should have an address array called spender address and and something called an u256 array called spender allowance. Okay, and these two variables will be able to get through this. Now there is an existing here that data location must be memory or call data in the parameter function. Now let's debug this error. This is an important part of Solidity. So what does this mean is key whenever you have something which is taking a consecutive part of a memory, an array does that. So you would be calling memory called at our storage, which would establish where the function parameter data would be stored. So these parameters, where will it be stored? Okay, so once we put the memory here, this will be able to go, and similarly let's put memory here, and this will be okay. Yeah, and declares spender's allowance. Oh, I mean, damn. Okay, we need to change the variable name. Let's put an underscore against it, and let's put an underscore against it. So basically I just avoided same variable names. Now, oh, fuck. Now what happened? Now let's run a for loop. Okay, now we need to ensure that the spender addresses match the spender allowance array length. Basically, let's say we have two children, so we need to pass two value of allowances, not more than that or less than that. So let's make an error spender value mismatch. Okay, and then here we can have if spender's dot length is not equal to whatever the problem is. And now let's run a for loop. U into 56 I is equal to 0, I less than spender's address allowance dot length I plus plus. Now something that we can do to save gas is we should store this in a variable, as every time the loop runs this will use it. So let's u into 56 length is equal to yes, and then we can just do this instead of this. We can directly use length. So this will ensure that the function call is not reiterating through spender address to find the length of it. It is finding it once and then using it in the loop. Okay, now the spenders will be set, and when we get here and we say emit, we emit something, an event that will show us event spenders set, and whatever spender set. Okay, so we will emit it every time a spender is being set, so that will be easy for us to know how much of money has been allocated or allowed. Now we have created deposit, we have created set allowance. Now we need one function that will be able to withdraw, and then some getter functions. So let's create withdraw first, and then we will create whatever the getter functions we need. Getter functions are basically the functions that help you get the value from private variables or something like that, which are not easily accessible, so you have to reiterate the contract. For example, let's say I want this spender mapping, okay, spender allowance mapping. So how will I return it? I'll have to reiterate through the complete by 0 1 2 3 whatever addresses I have. So instead we create getter functions. Okay, now we need to first figure out that what is a spender allowance. So let's imagine how the contract will have. So address 1, we will have 1 ETH as an allowance. Address 2 will have 2 ETH as allowance. Okay, that's the whole process of this. Now we want to ensure that address 1 only withdraws 1 ETH. Okay, so let's make an error which says not enough allowance. Okay, now we say not enough allowance here, and then when we go down here, we first need to check. This will also be an external function basically, as we want to save gas whatever. If spender allowance dot message dot sender is less than, oh, I don't want to call all of this, I'll explain it as we go. Spender allowance is message dot sender, so spender allowance array from for message dot sender is less than the amount, then we revert with not enough allowance. Okay, if it is, so we just transfer that amount of money to the message dot sender. Okay, now this should be the only spender, so this can be only called by spender. So modifier only spender. If so this is something that we can do, or we reiterate through the complete array. Let's see if we have a better way of making only spender. For now that's okay, as if there is somewhere in here. Now do we need to minus this amount from the person's allowance? So should we do this? We did this in case of the bank. Where was this? Yeah, we did this in place of the bank smart contract, as we had an allowance, so we should actually deduct this from their allowance. So spenders allowance message dot sender, as some naughty child will be able to extract money twice his allowance. So if I withdraw 3 ETH and still the allowance is 3 ETH, he or she can again withdraw 3 ETH from the contract. So that's what we are ensuring with this. And then we need to call something that we called yesterday, which is the message.sender.call is equal to message.sender.call. And now we can directly go for that underscore payable is equal to amount, or we can do things that we did yesterday. Okay, so let's go for that, which we did yesterday. Message.sender.call value is equal to amount, and if success true, then we go through, but if not, then withdrawal failed. Okay, so if not success, reward withdrawal failed, else emit withdrawal success. So let's sender amount. Let's copy this. Let's make an event. Withdrawal successful, and whoever has deployed this contract will get to know that a child or some other wallet has extracted money from this wallet. Now there is something called deploy script. This is what we written yesterday too. And now let's get to something called deploy script. So the script folder, let's make a file called deploy shared wallet dot s dot sol. Now what does this ensure us is that we can directly deploy the contract without interacting with the command line again and again, as that becomes very tough for us to understand how the things are working, how the, like, it's very difficult to debug for us. So let's go here and then vm, no, wrong, fuck, I'm just trying to write the contract. SPDX, this is also a type of contract. Just this .s.sols ident lets the Foundry and Forge understand that this is a deploy script and not the main contract. Okay, we ensure that the Solidity versions match here. Now what do we need for this? We need something from this lib which is called script.sol. Now where do we find it? We go to src, and I hope this is here. No, it's not here. Scripts, let me find it, and I am sure there is, it is here. Not here, but I think there will be here. Script.sol. Oh, sorry, I was just not able to spot it. So this script is something that we need the contract to be inherit, like it should be an instance of the script. So we import script from forge std slash script.sol, and then we import our contract, which is what we, oh, I guess this is the naming problem. So we import script from forge std, and then what we do is import shared wallet from shared wallet.sol, okay, which is here as we go there. And yes, now what is this problem? I'm not sure why is it happening, because I can see a script here. We'll go through this as we debug this contract while we deploy it. What is it exporting? It is exporting a script contract. So we are importing a script contract. I think this nah. Let's try without name import forge std.script.sol. I'm not sure. Let's write the contract first. So contract deploy shared wallet. Yeah, it got away. Is script. Okay. Now there is something called VM. Now VM is a very important tool in Foundry. Let me find this and let's search for VM. Is there a search option? Yes, VM. Yes, VM is like a cheat code library in Forge and Foundry, so which helps us mock things. Now what is mocking? So we are deploying this shared wallet. Oh, where is it? Yes, so we need to make an instance. So making an instance for the shared wallet, which will be done using VM. So we need to import VM. Let's fix this error first. I'm not sure, this should not be an error actually, but okay, let's debug this. Now the debugging step for this is, first, that's this problem in my ID. I just reload window and sometimes the imports are solved. Let's see if these imports get solved. I guess it did get solved. Okay, it did get solved. So now any deploy script has a function run, which is the main external function that deploys the contract. Okay, now this will be an external, as we'll call this, from outside the contract. Now vm.start broadcast is something called a wrapper, and between the wrapper stop broadcast. These are the two wrappers that ensure and wrap that this contract will be deployed under this environment only. Okay. Now, who calls the contract becomes the message.sender, right? So let's go here and say shared wallet is equal to new shared wallet. Okay, that's what we need, and deploy to, and owner, we get the owner, and we don't have any balance for now. So let's keep it simple. We will deposit money into the contract. And oh yeah, something that came to my mind is, what if this contract is initiated and the allowance is set, but the contract itself does not has that amount of money. So we need to see while setting allowance if the contract has that much money, right? Let's think of this. Okay. So, yes, we'll do it in the loop. So if spender allowance I is greater than the balance of address this. So balance of gives us a function called, oh, this is not used. Damn. How do I find the balance? Yeah, I guess this is the word. Oh, we don't know this. So let's go and how to find balance of contract and Solidity. I guess this will be very easy. Address this dot balance. So I just misspelled this. Address this dot balance. So if it is greater than address this of balance, we revert and say not enough allowance. No, we do not say not enough allowance. We say not enough money to allow. Okay. Yeah, and not enough allowance. Oh, sorry, not money to allow. And similarly, we will do this here. So if address this, not enough money to allow, basically that's what we need. So even if someone, let's say this guy has, the contract has 10 ETH and this guy both have allowance of 6 ETH and let's say 5 ETH, yeah. So if he or she withdraws 6 ETH from this, this guy cannot allow it, right? They cannot withdraw their money. So this is sort of a good check that we understood while we were writing the deploy script for this. Now there are two cases that we can follow. We can either write tests for that, or we can directly go for writing the and deploying the contract and interacting with it. Okay, so I will try to write the tests, but I guess AI can do better in writing tests than us. So let's call this deploy script. Let's just do a forge build first, and then we will try and write tests. I'll show you how the test cases work. Oh, was my screen visible enough? I'm not sure. But was it this resolution? Yeah, I guess we'll do that again if it does not work. Yeah. So now how to call a script, okay? How to call a script using forge. How to call a script using forge script. Okay, forge script. And there is a debug, there is a gas, everything is here. This is something like we use in forge create. So what do we need? We need a .env, and what else do we need? We need a terminal running Anvil. Okay, now we take a private key from here and we put it as a private key here, and RPC URL is equal to HTTP, and boom. Okay, cool. That's all we need for now. So this guy, the guy will be the owner. So now we need to have some getter functions here. function get balance. So this will return us then get allowance, and yes, and get owner. Yeah, get spender allowance. I guess we did this. These are some getter functions that I wrote using AI. So these small things that we can tweak and add using AI to just like decrease our effort in writing these things when do not need a lot of brainstorming. I don't mind relying on AI for these. And I just want a new terminal. I don't like this yellow. Yes. Now let's call for script, right? Script dot deploy shared wallet dot sol, and I think we need to write this deploy shared wallet. What's the name is deploy shared wallet. Now we need a private key for that. Private key, private key, RPC URL, RPC URL. And what else we need? We need a broadcast. So private key was not supplied as we have not sourced the envn. I hope this works. I mean, it will work. I'm not sure if it not won't work. So yes, now we see a better log than we were seeing yesterday, right? This is a better log as compared to the log that we written last time. We get a contract address, we get an owner, we get deployed to. So these are the logs that we have in console log. Let me just do this. These are the console log. These are the logs that are made or generated using the deploy script. Now we can directly interact with this contract and deposit money from this. Okay, deposit money into it. Let's try to deposit some money into it, and let's just put the contract address. Okay, by the way, this owner actually matches with the guy who is the owner here. This guy 2666 2226 whatever. And let's go for contract address is equal to I'm not sure. Yes, contract address. This is where the contract is deployed. Okay, now we source the env again, and we cast send contract address. We can actually write interactions too for this contract. We'll do that in later parts of the series. Let's just use the command line and get familiar with how contracts are called, how contracts work. Now we have this deposit function which is payable and only owner, so we don't need anything. Now we need a value flag, and let's deposit 10 ether into this. And when we are depositing 10 ether to this, we need to ensure that who is paying for this. So private key RPC URL will be RPC URL, and I guess this is what we need for the transaction to go through. And yes, the transaction has gone through. This contract will have money. Now we will not actually go for address and balance. We will go for get balance function. We will call contract address. I just need to do this. Okay, cool. Contract address, and we will call the get balance function for this. And on get balance, we need to actually write down what the return type is, so that it is easy for us to actually read the values. And RPC URL, and we get 10 ether, right? So now the money has been deposited into the contract. Now I get that these scripts would take a lot of energy to write. Like if you want to set, like let's say you want to set allowances, right? So how do you write a cast script for this function? Let's use AI. Okay, this cursor thing is stupid. It does not know anything. Let's open ChatGPT and let's open a temporary script. Give me cast command for this. with placeholders or rest for address values. Okay, that's it. I guess we have 10 each. Two placeholders. We need two people. Cast and contract address. Your wallet. From, I don't actually need from. We are not in ETH. Multiply our ETH values by 1 into 18 if needed. Cast tool needs to RPC URL if we're connected to RPC URL. Boom, baby. Okay, I think this will work. So let's copy this and let's clear this terminal and use this. Now we need a dollar contract address here. Okay, now we have called the set allowance function, and then we have two arrays here. So these are good values that we have 10 ETH here, and we need only, like, let's say how much ETH this is. Yeah, how much ETH this is. Way to ETH, and let's open this up. This is 1 ETH, okay, and this is 5 ETH, so we have enough money in there. Okay, now in this we need two addresses. So where we get those two addresses, we get this one, and we go for this, and let's go here and let's take this, and oh, why is it not working? Yeah, now it works. Yep, these two addresses. Now set allowances is also an only owner function, so the owner has to call this contract. Now private key is equal to dollar private key, and RPC URL needs to be RPC URL. Let's call this okay. Now I know what the problem here is, but let's try and use this as our prompt to AI, because these are the errors that we will actually, this is something that I can actually do and get errors for, right? So what did they do is they wrapped the whole argument in double quotes, or they removed the double quotes. Okay, basically it was misinterpreting, and then it says no matches found. Okay, so there are no variables here. So let's try and do the .env here. Okay, so spender1 is equal to spender1 is equal to this, and spender2 is equal to this. Simple. Okay, and let's source the env again. Let's do this instead of dollar spender 1 and dollar spender 2, and private key no matches found. Okay, this is again an error. Okay, so I think we need to write a deploy script for this. Let's try this last thing. So expected digits or the prefix for an empty string. Now what can we do here is we can modify this contract. I mean, we should not modify this contract. We need to write interactions for this. But if it does not work, then it does not work. So once we are through writing in let's give this an address and memory spender allowance, and we call the set allowance here. Okay, set allowances and spender address, spender allowance. This will be very easy for us, so we'll just use this set allowance function. And I hope this is not external. No, it's not external. Okay, so we need a redeployment. For better ease, we are not redeploying it again. We will just reset Anvil so that we get the same addresses. Anvil is very deterministic in nature. It will give you the same addresses again and again. So the constructor now needs to be filled. Okay, so this cannot be empty. Do you understand that? So let's define and address memory spender addresses. Okay. And no, we don't want this. We want to allow the values. Okay. We want to 0 should be equal to this, right? Should be equal to this, and I guess in double quotes, that's the key here, and this, and for this will be this. Now cannot be expected. Okay, we can directly go for the addresses here. Oh shit. Now what is the error here? There is no error here. These are direct addresses, and then we go for address memory spender allowances. Now spender allowance 1 should be equal to 1/8 and then 2/8. Let's just ensure that these are right values. Yeah, it's still 1/8. And u into 56 is not explicitly converted to, okay, yeah, this should not be actually this. It should be u into 56. Yeah, it goes to, yeah, we need this, and here what it is go 0 arguments given but expected 2. Now it's solved. Yep. Let's call the script again and let's see if it works. Forward script, 3 guesses, and let's see if it gets run. Deploy shared wallet, return 76, array out of bound, 0 and 1 address is there. How can array be out of bound? So compiler is running, and you deploy shared wallet, spender addresses and spender allowances. Now what does it do? Set allowances function. How can array be out of bounds? Spender address dot length. This should not be a problem. I is stopping at one length below this. Now I'm not sure why is this panicking, but let's try and do something else here. Let's go for this and share. I'm not sure why this should not work actually. SD wallet, shared wallet, SD wallet equal to, yeah, let's just run forge clean. I want to clean all the RAM here, and we'll redeploy the contract and rebuild the contract first. SD wallet dot owner. Let's run forge build. Oh, there is an error. No, that's not forge build. Compiler is successful. There is something in the deployment script, right? So let's think of how can we actually use this deploy script and debug this error. I know this video has been very long, but we have to solve this here. And there is this error. Okay, array out of bound index. So why can this error occur? As we have changed the deployment script, so we go for deployment script, and then we will provide it with the, I know why this is failing. There is some sort of panic here which gets triggered by Solidity, as it is very memory safe. It lets you be very memory safe. Okay, so this is the constructor that we are calling, and the set allowance function is this. Boom. Yeah, it is not JavaScript. You cannot just say this. So we have to actually give it that how much money it will be and how much of space will this array take. So these two arrays cannot be like this, and we need to ensure this. Yes, a little hurdle in this. Now where were we? We were debugging using ChatGPT, which just gave us this, but I guess this would fail again. Yeah, it fails again. Now, as I just told you, Solidity needs to have a very clear idea of how much memory it needs to allocate to any array. You do not actually go overboard for this. So we just give it a new address, and this two values will be the two values that are here. Similarly here, spender allowances. Now let's go through this. I guess you will be thinking that this will go through, and it will not go through as the storage memory. Okay, yeah, this is not the error that I was expecting. This is just a small typo. Yeah, this fails with not enough money to allow. Now what does not enough money to allow means? While we are setting allowances, we are checking that if the contract has that much money. So when a wallet is initialized, you need to actually deposit that much money to set the allowances later. So now how do we do this? Remember the value tag that we had? So we will use that value tag, right? The value would be how much we need? 10 ether, let's say. Okay, now that's what we will do here. And if we don't do this, right, so what's gonna happen is 10 ether will be paid to the constructor. Now let's see. I guess we are missing a very important thing, which I'll come to in a bit. And this goes through. As I made a little change here, I made the constructor payable. Where is the constructor? I made the constructor payable, which was not before. So I made the constructor payable so that we can directly interact with this contract. Now we have a contract address here, which we will go for contract address, right? And let's source the env here, source the .env here, and let's interact with this contract. Cast call dollar contract address. Okay, and then we will check if it has enough money. So get balance, and you would do 56, you would do 56, and rpc url. Okay, cool. It has 10 ETH here. Let's see if this is 10 ETH. I hope it is 10 ETH. I guess this is 10 ETH, right? Now, what do we need here? We need to see if there is enough money to withdraw out of this, right? So the allowance that we have set for user 1 is 1 ether and user 2 is 2 ether. So let's find the private key of this guy. The C is second and this is the second. Let's go spender 2 pvt is equal to this, right? And let's try to withdraw money out of the contract. Okay, so this is the last interaction for the video. We will write test cases for the next contract that we go for. We will not write the deploy script. I'll get it done by the ChatGPT, but this code on GitHub will have the test scripts. So if you want to just take a reference at how the test scripts look. So now let's go to the contract and let's call the withdraw function. Withdraw. Okay, and this needs a UN256. 256, and this will also need a UN256 by only spender, which is spender guy, and amount will be equal to, let's say, 1 ether. Okay, and then we use rpc url private key will be equal to spender to private key. Okay, let's go through, and this goes through, right? This goes through, and let's get the balance of the contract. It is 9 ether. Now let's get the balance of this guy, like which guy? Spender 2. Yes, so we'll go for cast call balance. I'm not sure how does it go, arc, and yes, this will work actually. So how do we go for get balance solidity cast balance address this balance cast? How do we use the cast here? Cast balance. Yes, the founder cast balance of dollar spender 2. This will be more than 1 ether, as we see that every is by 10,000 ETH. It is a little more than 10,000 ETH here. As we go to this, and it is more than 10,000. It is almost 1,000 ETH. But why is it not 1 ETH as they have called the functions and the gas has been deducted? So yes, folks, that's all for this video, and I hope you had fun. I hope this was not boring enough. Even if it is, I love doing this. So yeah, see you tomorrow again with another video. We are getting more complex in this. We'll write test scripts for this too. Thank you.